This is the second video for the semester 2 review, and just on gases, which we recently have done. So we'll start off with gas pressure and temperature. So if I have a force over an area, I'm just going to take my 150 newtons divided by 0.05 to get 2,300 newtons per meter squared, or that's also the same as pascals. Now to get my Kelvin, I take my degrees Celsius plus 273. So 35 plus 273 gives me 308 Kelvin. And now what about these gases? So if the pressure of a gas increases, what happened to the temperature of the gas? This is Gay-Lussac's law. We know that that's directly related. So the temperature increases to make the molecules move faster, and therefore you get a higher pressure. But volume stays constant. Now what about a volume of the gas increases? What happens to the pressure? This is Boyle's law. As you expand volume, there's more space for molecules to exist in. Therefore the pressure will now go down. The volume of gas decreases. What happens to the number of moles of the gas? Well, this is the ideal gas law. If you take away gas in a volume, then we'll see that the volume will get smaller if you don't have as much number of molecules bouncing around. Okay, so they'll take up less space. So that's ideal gas law. All right, next one. The temperature of a gas increases and the volume decreases. What happened to the pressure? Well, increasing the temperature of a gas generally increases pressure, but this is the combined gas law, so we better double check. The volume decreases, that also increases pressure. So we have two conditions that cause the pressure to increase for a gas. So even though it's the combined gas law here, since both increase the pressure, we assume then the final result would be an increase in pressure. Temperature of a gas decreases. What happens to the volume of a gas? Well, this is Charles' law, and we know that that's directly related. So if the temperature decreases, the volume of the gas will then decrease because the molecules aren't moving as fast and not spreading out as much. Now let's look at some calculations here. A gas has a volume of 3.5 liters, and then we have a pressure and temperature. Determine the moles for this. Well, this is Pivnert. PV equals nRT. So we put our pressure 88.5 multiplied by volume of 3.5. Equals N, which is what we're solving for, number of moles, R, the 8.31 gas constant, times temperature of 293. Remember to convert Celsius always to Kelvin. Our moles, 0.127 when you're done solving it. Now, what about a gas at a volume and a pressure and a temperature? And we got to determine the new volume at STP. Well, remember, STP stands for standard temperature and pressure. Standard temperature, 273 Kelvin, and pressure, 101.3 kilopascals. So we take 95 times 45.5 times temperature 2, which is 273, equals pressure 2, which is 101.3, times volume 2, which is what you're solving for, times 303, which is temperature 1. Volume 2 turns out to be 38.4 milliliters. All right, now let's go through some more gas laws here. A gas has a pressure of 55.6 kilopascals at 50 degrees Celsius. Determine the temperature and when its pressure changes. Okay, so this is Gay-Lussac's law. So we take our initial pressure, 55.6 times temperature 2, equals pressure 2, which is 77.6, times temperature 1, or 323. We're solving for T2, you get 451 Kelvin. Now, next one, the gas has a volume and a pressure given. Determine the pressure when the gas volume doubles. This will be Boyle's law, so 85.0 times 66.7 equals pressure 2 times 133.4, which is your volume 2. You find out the pressure 2 is 42.5. And basically what happens then, the pressure goes down by 2 when the volume doubles. Now finally, we have Charles' law, I believe, here. We have a volume and a temperature initially given. We need to find the volume of the gas at standard temperature. Now remember, standard temperature is 273 Kelvin. So I take my initial volume, 99.5, times the new temperature, 273, equals volume 2 times the beginning temperature of 303. And volume 2 equals 89.6 milliliters. Okay, we'll finish up with standard conditions, stoichiometry. I'm not going to do non-standard for this test. So we have propane with oxygen making carbon dioxide and water. A combustion reaction, no doubt, because we have a carbon compound plus oxygen making carbon dioxide and water. Okay, for the first part, all we need to do is multiply these by the mole ratio. So we have 25.6 liters of propane, and we want to know how many liters of oxygen there is. Well, oxygen has a 5 in front of it, so I'm going to put the 5 there. This one has a 1 in front of it, although not written, I'll put the 1 there. Notice how the 5 goes on top. because we're solving for oxygen over here. So keep the 5 on top and put the 1 on the bottom, because that one we're not solving for. That's the one on the left side. Remember, whatever's on the left side goes on the bottom here. Whatever's on the right side goes on the top here. Now let's follow up with the next two. 17.7 liters of oxygen. And we want C. We want to go to carbon dioxide here. Okay. I don't have the proper label here. This should be CO2 here, but that's okay. We can fix that. So 17.7 liters of oxygen. There's a 3 in front of my CO2, so I put a 3 there. Okay. And I want to look at our oxygen, which is a 5. So there's a 5 on the bottom there. Okay, so I'm going to take 17.7 times 3 divided by 5, and I'll get 10.6 liters. And again, that should be CO2 there. Okay, now what about the next one? We have liters of carbon dioxide. We want to know how many liters of propane should have reacted. Now that's our C3H8. Okay, and carbon dioxide is CO2. So I see a 1 in front of C3H8. Okay, which is our propane. Okay, and there's a 3 in front of our CO2. So there should be a 1 here on top and a 3 on the bottom. Because remember, what's on the left over here goes on the bottom down here, and what we're solving on the right goes on top there. Okay, last but not least, now we have grams going to liters. So the first step, of course, 18.8 grams of C3H8 times 1 mole over 44, okay, grams. That's the molar mass of C3H8. I'm going to do a 3 over 1. And where is that coming from? Let's go back up to our reaction. We're trying to find carbon dioxide here. So there's a 3 for the carbon dioxide and a 1 for the C3H8. Remember, we're going to put that one on top because that's what we're solving for. We'll put this one on the bottom because that's what was given on the left. Now this last step is 22.4 liters per 1 mole. All gases at STP occupy 22.4 liters. So we're not going to go in molar mass here. We're going to put 22.4 liters over 1 mole. And that gives us 28.7 liters of CO2. Now I've got grams of propane again, same process, times 1 mole over molar mass. We're going to oxygen this time. Well, oxygen has a 5 in front of it from our balanced equation. And that's right there. And of course, we solve a 1 for the propane. And then we finish up one more time with the 22.4 liters of oxygen per 1 mole, because remember, all gases occupy 22.4 liters per 1 mole. And we'll take 14.4 divided by 44 times 5 divided by 1 times 22.4. And that gives us 36.7 liters. And that's our review.